All right, so in Chapter 9, Section 3, we're dealing with this chi-squared distribution, and it's going to help us figure out confidence intervals for variances and standard deviations. So on something like this, we're finding critical values, so we need to go to a chi-squared calculator. So I'm going to go to my StatCrunch. And they give us some information. The sample size was 25 on mine. It was a 95% confidence interval. So if I go to my calculators and go to a chi-square, it's going to ask for some of that information. So if my sample size is 25, that means that my degrees of freedom is 24, similar to a t-distribution. If I'm looking for a 95% confidence interval, that means there's 2.5% to the left and 2.5% to the right. So if I'm looking for that lower 2.5%, I get this picture and it gives me the chi-squared value of 12.401. Double check that. 12.401. And so that's going to give me my lower bound. Well, actually, that would give me my upper, the 1 minus alpha over 2. So I need to, go back instead of putting 2.5%, put in the 97.5. That's 1 minus the 2.5%. So when I compute, I get 39.364. When I do my lower one, it'll be that 12 number. That's strange. I'm going to try the other number. See if that would have been it. 12.401. So 1 minus the alpha over 2. So that would be the 97.5% to the right. Sorry. It's kind of a weird way. So that means up to that 97.5% to the right. So that means how much area there is to the right. So this is how much area is there to 95% confidence interval. So it's backwards from rationale, finding these critical values. Not something that is a big worry. 39.364. Notice that graph-wise, that gives me 97.5% to the left, where the other one gave me 2.5% to the left. So just be careful with those as far as getting those right values. The way that they're constructing them, it's a little winky. This one, constructing a 90% confidence interval for a population variance. So similarly, how we did those in the previous sections, we're going to go to our variance stats, one sample, and whether we have a summary. We were told that we have the S squared is 12.4, sample size is 20, 90% confidence. And so when doing this in StatCrunch, we're just typing in the information that they give us. Confidence interval, we want to be at 90%. So it's going to give me my lower bound and my upper bound. So there's my lower bound and there's my upper bound. So 7.816, 0.82 to 2 decimal places. And so with this, we're going to be able to use this right here to help us through. very similarly to before. On some of the other questions, I want to look at number 5 because it's talking about a population standard deviation. So with the population standard deviation, we just have to be careful that we're computing variances on StatCrunch. So to go from variances to population standard deviations, we have to make sure we're square rooting our values. So if I'm trying to create a 95% confidence interval, I have the data. Let's open this one in StatCrunch. The answers that we're going to get are based off of variances. So what we'll have to do is just manually do a square root to find our answer. I'll bring up my other calculator. So if we're doing variance, we have a sample, we do have data. So we're looking at var 1, we're doing a hypothesis test, we want it to be a 95%, so we're good there, and I'm going to compute. So this gives me my lower limit and my upper limit for the variance. So for the standard deviation, I'm going to have to take the square root of that lower limit, 48.43359, and that's going to be the lower limit for the standard deviation. So I'm going to get 6.959. 6.959. $6.959 is my lower, and then my upper is 278.233. 278.233. 278.233. So this should be what we're looking for. Chance, so it's not, so it's going to go to B. So let's just get our right numbers in, because we're looking at the confidence, not a chance. It's not a probability. So construct interpreting 95% confidence, and so I'm liking that one. Oh, I didn't take the, gotta take the standard or the square root of that one. Sorry. 278.233. 278.233. Let's see if that gets us close enough. 16.680. That's where a lot of people make a mistake on this one, is not taking the square root when you're doing these. Just make sure you take the square root and you should be good. Because again, StatCrunch will give us variances, not standard deviations.